1, you're clear. Watch your left and right.
In the ever-evolving landscape of warfare, where the skies are a contested domain, the rise of man-portable air defense systems, or MANPADS, marked a turning point. These shoulder-fired missiles, designed to be operated by a single soldier, revolutionized ground troops' ability to counter aerial threats. Initially conceived in the Cold War era as a way to level the playing field against powerful air forces, MANPADS quickly proved their worth, empowering smaller militaries and guerrilla groups with a potent defense against aircraft. From the battlefields of Vietnam to the modern conflicts of today, like the Ukrainian-Russian war, MANPADS have become a ubiquitous presence, feared for their ability to bring down helicopters, jets, and other low-flying aircraft. Their impact has been felt not only in military engagements, but also in the realm of civilian aviation, where the threat of MANPADS attacks has necessitated the development of countermeasures and heightened security protocols. Many pieces of military hardware from the Cold War era that were thought to be obsolete were given a chance to prove themselves and find a new field of use during the Ukrainian-Russian conflict. While some of these weapons get their first, albeit delayed, taste of battle, for others it's business as usual to operate in the face of hostile fire.
Activate missile when ready.
Activating.
Okay, should elevate. Missile away. Fire.
The Stinger MANPAD, a veteran of the Soviet-Afghan War, was deployed again to fight the Russians. And since then, the Russians have learned to fear and respect this weapon system so much that they sent one of the captured Stinger missiles to Iran for reverse engineering. The Stinger missile, formerly known as the FIM-92, was developed by the United States as a shoulder-fired, surface-to-air missile system. The Stinger's primary purpose is to provide infantry units with a highly portable and effective means to engage and destroy enemy aircraft. As a result, it has played a significant role in the evolution of modern warfare, enabling smaller forces to challenge the air superiority of their adversaries. The development of the Stinger missile began in the late 1960s, prompted by the need for a more advanced and effective portable surface-to-air missile system. The US Army awarded the contract for the design and production of the Stinger to General Dynamics in 1972. After a series of tests, the missile entered service in 1981, replacing the less effective Red-Eye missile system. The Stinger missile system has undergone multiple upgrades and improvements since its introduction in 1981. It consists of three primary components: the missile itself, the launch tube, and the Identification Friend or Foe (IFF) interrogator. The missile has a length of 1.52 meters, a diameter of 2.8 inches, and fins measuring 3.9 inches. The weight of the missile itself is approximately 22 pounds, while the total weight of the missile, including its launch tube, integral sight, grip stock, and Identification Friend or Foe (IFF) antenna, is approximately 34 pounds. It can engage low-altitude enemy threats up to 2.36 miles away and has a targeting range of up to 2.98 miles. The Stinger is propelled away from the operator by a small ejection motor before the main two-stage solid fuel sustainer is engaged. This causes the Stinger to accelerate to a maximum speed of Mach 2.54. The missile's high explosive annular blast fragmentation, or HEABF, warhead is designed to maximize damage to aircraft by targeting the most vulnerable components, such as engines, fuel tanks, and control surfaces. The warhead has 2.25 pounds of HTA-3 explosive, which is a mixture of HMX, TNT, and aluminum powder. Additionally, the warhead has an impact fuse and a self-destruct timer that goes off 17 seconds after launch. Also, the Stinger missile features a proximity fuse that detonates the warhead when it comes within a predetermined distance of the target. This increases the likelihood of damaging or destroying the target, even if the missile does not score a direct hit. The FIM-92J's proximity fuse has been upgraded for greater reliability and effectiveness. Stinger is guided by an infrared passive system. The Seeker has the ability to focus on moving as well as stationary targets. There have been upgrades to both the Seeker and the computer. The FIM-92B and later models use a Seeker that detects both infrared and ultraviolet light. The FIM-92K makes use of a data link to enable a remote sensor to acquire a target outside of the Stinger's sensor's acquisition range. Using the data link, the missile is able to make mid-air adjustments to its course and successfully acquire the target. One of the key advantages of the Stinger missile is its ease of use. The entire system weighs approximately 35 pounds, making it highly portable and suitable for infantry use. The launch process is straightforward and requires minimal training, further enhancing its usability. Additionally, the IFF interrogator helps prevent friendly fire incidents by ensuring that the missile only engages enemy aircraft. Throughout the Stinger's deployment, there have been multiple variants with improvements in range, guidance, and lethality. Some of these include the FIM-92A Basic Stinger, FIM-92B Stinger Post, FIM-92C Stinger RMP, FIM-92D Stinger Block 1, and the FIM-92J, which features an improved Seeker that allows for better target acquisition in adverse weather conditions and increased resistance to countermeasures. A single Stinger missile costs around $139,000, adjusted for 2024. Okay, Stinger is a classic with a somewhat orthodox design approach. Well, this next one is a bit different. Imagine piloting a low-flying combat aircraft or operating a military drone when your missile lock warnings blare with sudden dread. Something is hurtling toward you at 3 times the speed of sound, immune to your countermeasures. As you attempt desperate evasive maneuvers, the missile disgorges 3 tungsten darts, a deadly reminder that the worst is yet to come. This is your chilling introduction to the Starstreak missile. Just like the Stinger, Starstreak missiles have proven their relevance and effectiveness in the challenging battlefield scenarios witnessed in Ukraine. The high-speed, low-flying drones and aircraft, which are increasingly prevalent in modern conflict zones, have shown vulnerability to these short-range air defense systems. The Starstreak missile is a renowned surface-to-air missile currently in service with the British Army and produced by Thales Air Defence, formerly known as Short's Missile Systems. The missile's development dates back to the 1980s, with the primary goal of replacing the existing Rapier missile system, which was a key element of Britain's air defense arsenal. The development process of the Starstreak was a decade-long endeavor. It started in the late 1970s, and it went through a series of comprehensive testings and refinements before it was officially accepted into service in 1997. The main goal of the Starstreak missile system was to tackle the shortcomings of its predecessor, namely its vulnerability to electronic countermeasures and lack of versatility in engaging low-level, fast-moving targets. The Starstreak missile system has a unique tri-dart design that distinguishes it from conventional missile systems. Upon launch, the missile propels itself towards the target, and when in close proximity, it releases 3 separate dart projectiles. Each dart is equipped with its independent explosive warhead and guidance system, effectively multiplying the missile's chances of successfully neutralizing the target. This tri-dart design is one of the primary reasons the Starstreak is considered one of the most lethal short-range surface-to-air missiles in existence. The Starstreak missile measures approximately 4.9 feet in length and has a diameter of 5.1 inches. Despite its seemingly small size, the missile weighs approximately 37.4 pounds. This heavy weight, for a missile of its size, is attributed to the advanced, dense technology and design elements incorporated into the Starstreak system. The range of the Starstreak missile is another noteworthy feature. It can engage targets at distances of up to 4.35 miles, making it highly effective against low-level aircraft and unmanned aerial vehicles. The missile's range is augmented by its superior speed capabilities. With a top speed of around Mach 3.5 or 2,685 miles per hour, the Starstreak is often referred to as the fastest short-range surface-to-air missile in the world. This high speed makes it a formidable weapon against fast-moving aircraft, allowing little time for enemy pilots or drone operators to take evasive actions or deploy countermeasures. Further adding to the Starstreak's utility is its adaptability to different launch platforms. It can be fired from man-portable launch systems, making it a versatile asset for infantry units. It can also be deployed on helicopters and ground vehicles, adding to the defense capabilities of these platforms. The lightweight and compact size of the missile makes it an ideal choice for mobile air defense units, and its adaptability enables it to be deployed in various operational scenarios. The guidance system of the Starstreak missile is another interesting aspect of its design. The missile uses an optical guidance system, requiring the operator to maintain the target within sight until impact. Although this may present challenges against fast-moving targets, it also makes the missile immune to many electronic countermeasures. This is because the optical guidance system does not rely on radio waves, which can be jammed or spoofed. Thus, the Starstreak missile provides a significant advantage in electronic warfare environments, like in Ukraine, where both sides are using the latest electronic countermeasure systems. This concludes our episode that provides a glimpse into the Stinger and Starstreak MANPADS. So, what do you think about these formidable weapon systems? How effective are they? What other pieces of military hardware would you like us to cover in our future episodes? Also, if you were lucky enough to operate one of the weapons mentioned in this video, please comment.
Alright, so this is pit 1. Are we clear to shoot?
Outlaw, you in the pattern?
Oh my god.
Destination. Pit 1, you're clear. Watch your left and right.
Roger, solid.
Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching, and see you in the next one.